And we're going.
All right.
Hi. Hi, I'm Gary First. I sent out some WebEx invites. Glad so many people managed to find this meeting. David, introduce yourself.
I'm David Black, one of the co-chairs of this three-ring circus, better known as the Transport Area Working Group.
And I'm Wes Eddy. I'm the third co-chair of this working group.
So I guess for this particular meeting, Wes is going to be the main co-chair and try and lead us through the course ahead and figure out what to do. So Wes, are you just going to go through the chair slides? Or do you want me to do that?
We have to start with the note well, as usual. So the standard IETF note well about the way that we do intellectual property. And some instructions on participating in this WebEx interim. Etherpad for blue sheets. So people are supposed to head over to the Etherpad link from the IETF webpage and record your name and organization there. Jabber is up for remote chat. And there are then some further instructions on how to use the WebEx chat. So the goal is to use the WebEx chat for queue management. So people who want to speak, we're asking you to send a plus Q into the WebEx chat, and we'll be watching that so that then we can call on you when it's time to speak. That way we don't have people stepping on one another since there's no mics to line up at physically. And if you're not speaking, we're asking people to be on mute, please.
If somebody makes your point for you, please send -Q. In addition, we working group chairs will try to be very good about joining the queue with plus Q when we have remarks to make as individuals, so as to avoid taking undue advantage of our positions.
I think we've front-loaded the work from this side of finding a taker. Thank you, Jake. And I guess this is kind of a focused meeting, so the note on submitting drafts isn't as important, but for anyone that doesn't know, if you're submitting any drafts, add TSVWG to the ID title.
Please go on mute if you're not speaking, and doing it at WebEx will protect the meeting from interesting things on your links.
So there are some relevant working group milestones for the L4S documents. And also we mentioned the non-building PHP document here, all of which are adopted working group items that we've been trying to progress. And this discussion about what to do with ECT1 is something we need to get resolved before we do that. And this is interim number 2, and this is a quick overview of the agenda. So we're already doing the chairs update, and we have one set of charts, and the idea that is to go through that twice, actually. So we a quick run through so everyone gets a sense of what's there to be talked about, and then we want to do a slow walkthrough where people have a chance to discuss each sort of question and point. And an analogy is like when you go to the buffet, looking at what all is there before you decide what to put on the plate. So we want to try to avoid having discussions where we're referring to things we haven't got to yet in the conversation. The goal of doing a quick run through first, and then hopefully we'll be able to synthesize some kind of summary of what the result of the meeting is by the end. So just to recap, please add your name to the blue sheets because I see we have 47 people on the WebEx, and hopefully we have 87 names in the blue sheets. And yeah, please use +Q if you want to talk in the Jabber queue. So, slide decks here. Am I sharing the ECT1 slide deck now?
The game plan for this deck is the chairs are going to go through it. The first approximation, Wes is going to handle all of the working group stuff. Gory and I will be trying to do Socratic dialogues when we get to slides that contain blue material for L4S and gold material for SCE, with the exception, I think there's one slide for each of them, which is entirely blue or entirely gold, which will turn over to the team, the individual teams, groups, whatever you want to call them, to present. Ready to go with this one?
Okay, maybe I need to say one thing before we start, which is, I'm Gory still. When we put this slide deck together, we had a process where we circulated the slide deck with the chair's contributions and some blank slides to each of the proponents of the two sets of internet drafts. And they revised them, they sent them back to the chairs moderated, thought, reconstructed the slides and distributed these again. And this went through several phases until we ran this particular slide deck. So the words in the blue boxes don't come from the chairs, and the words in the orange goldy boxes don't come from the chairs. But together they represent a picture of where we are, which we'll now try and guide you through.
This is not a perfect slide deck. It's the one we could put together that appears to be sufficient to organize this meeting. Please bear with us. It's been an interesting journey and we're not done yet. Martin.
Clarifying question. So the question at hand is the nature of the ECT1 code point, which is detached from the choice of L4S or SCE.
Let's go walk through a few slides and then come back to that to make sure we are clear on what is being asked of the working group.
Okay.
Wes?
Okay, I'm going to go.
Whoops.
These are not flipping in the order I expected. All right.
See if you can get to two. There we go.
Okay. So the key goal and for this meeting, the most important thing I think is figuring out what the working group wants to do here and now in 2020. So a number of years ago, actually when the sort of at the tail end of the AQM working group, as that was in the process of closing, there was L4S proposal came to the IETF, and there was actually an L4S BOF, and then eventually L4S was adopted in the TSVWG, and that was around a problem statement and set of goals working towards ultra low latency, low loss, and scalable congestion controls in the internet. And you know, one of the key L4S design pieces is without requiring the network to do transport layer inspection or per queuing and scheduling. We think that now, as we've seen the SCE proposal, there's one big similarity, which is both of them are aimed at providing scalable, reduced size of sawtooth kinds of congestion control algorithms. SCE is very focused on providing the high fidelity feedback from the network needed to do that. And essentially just that. L4S is also attempting to provide low latency, low loss for those flows. We think those are the key differences in goals between the two proposals. And when we come back here in the second round, I guess we'll be looking for feedback from the rest of the working group about what they're interested in 2020.
Right. This is David. The thing to emphasize on this slide is that the two proposals are going after different problems with different goals. First paragraph in each column is indicative of what that particular proposal intends to do.
Thank you. So the reason why we have to talk about this at great length is because both technologies have a way of using ECT1 that is different, and particularly both of them are different from sort of classic ECM. So RFC 4774 already describes that you can use alternate ECN semantics, but it describes that to do so, you use a DSCP in order to signal the alternate semantics. For the obvious reasons that DSCP isn't working well across the public internet, I think both of these proposals would rather use ECT1 without the DSCP scoping. So the key that I think we have pulled out is that L4S would like to use ECT1 as an input to how the network treats packets, and SCE would like to use ECT1 as an output to indicate how the network has treated a packet. So since these are obviously not compatible at internet scope, we can only have one of these things. And the goal of the meeting today is to figure out whether an input or an output is a more sensible thing to do. And there have been actually some great positions that people have been posting to the mailing list in the last few days, outlining exactly why they think one way or the other. We can talk about those when we come back through the chart deck. For people who haven't been, sorry, David, do you want to say something here?
Still on mute.
So for people who haven't been paying attention, this is a quick and I guess not very accurate, but decent way to think about input versus the output behaviors differ. So on the left, for traffic that's not ECN capable, the only thing the network can do is drop it, which results in large sawteeth and is sort of the current status quo for congestion control without ECN that we want to improve on. With a traditional ECN capable transport using ECT0, the network can keep dropping or it can add CE marks. So the CE marks currently still result in those coarse sawteeth. L4S provides the capability to treat the CE marks as a finer grained congestion channel. And it does that if the input packets use ECT1 so that they're basically identifying themselves as a different type of ECN capable transport. SCE, in contrast, still uses ECT0 to indicate an ECN capable transport, but then in addition to dropping and using CE marks consistent with RFC 3168, it adds the ability to switch an ECT0 mark to an ECT1 mark to provide that fine-grained congestion control signal to flows that understand it. So this was kind of a very brief, and the details are missing overview, but it shows you how ECT1 is being used differently by the two technologies.
This is Stuart. Can you guys hear me? I just wanted to make one comment here to reiterate what's being said here. When I was wrestling in my head about these two proposals, because SCE came along later, but I wanted to give it a fair evaluation. I didn't want to be one of those people who just rejects the new thing because we're already on a path. And I spent a lot of time thinking about it. And I think for me, the light bulb moment that helped me make the comparison is that we only have one code point left to use. And L4S is using that as an input code point to the network so that we can have two flavors of traffic flowing into the network that gives the network a hint how to handle those flavors of traffic. With SCE, that code point is being used as an output code point. So all traffic coming into the network looks the same. It can't make any declarations about what type of traffic it is. But on the output side, we have more fidelity to indicate small congestion versus big congestion. And I think that input versus output was what helped me wrap my head around it.
And that's the key decision we're going to be trying to make today, which is whether to use that one code point, which I wish I could split in half, but can't, as input to the network, as shown in the blue L4S box, or output from the network shown in the gold SCE box.
Okay, and now we have a chance where I think we want Bob to talk about L4S for a bit, and then we'll go to a slide where I think Jonathan will talk about SCE for a bit.
I think Greg is going to go through this slide.
Okay, Greg is good too.
Greg, let's keep this to 5 minutes apiece. 5 minutes here, and then SCE 5 minutes. 5 minutes on the next slide.
Okay, so this is intended as the quick walkthrough, I take it. So the slide starts off indicating, a key point in this discussion around the presence of tunneling and encapsulations on the internet. More than 50% of all internet traffic, by at least some metrics, is encrypted and or tunneled. And the key differentiators and reasons why ECT1 as an input makes sense are in the bullet list at the top. First off, it doesn't require access to transport headers because there's an explicit signal within the IP header with this ECT1 value. The network can then treat flows that support this new congestion signaling solely by looking at that IP header. Secondly, it can be supported by network bottlenecks that implement multiple types of AQM disciplines. In particular, FQ or flow queuing is one mechanism by which L4S can be supported, and also a simpler dual queue scheme can also be supported solely by, again, utilizing that ECT1 value as an input to the network. Supported by existing tunnels and encapsulations. There's been, again, a fair amount of discussion on that on the mailing list. Revolves around how exactly the ECN field is treated as are decapsulated from a tunnel, and whether signals that were applied along the path are propagated to the inner packet as it's decapsulated. And here, existing implementations, the L4S mechanism reached as the input is supported. it works in the presence of TCP ACK thinning. So the feedback mechanism with accurate ECN is feeding back a single signal of congestion is CE mark, and that is robust to ACK thinning. It's compatible with existing data center network deployments. So it aligns with DC-TCP mechanisms used in data centers and a lot of data centers currently. Finally, it eventually frees up ECT0. If you take a look back at the previous slide with the graphic, see that in the blue box, ECT0 doesn't appear. So the bottleneck can continue to support RFC 3168 and RFC 8311 along with L4S, and so it can support compatibility with any existing deployments of 3168 that use ECT0 as an input, but it doesn't need to long term. So the network could, the IETF could reclaim ECT0 for another purpose at some point in the future. For all of those points, the ECT1 as an output, so the SCE proposal doesn't achieve those attributes, and further, due to its reliance on Q and inspecting headers, I think layer 4 headers, it would essentially require all bottlenecks that want to support this new congestion signaling to implement something that inspects L4 headers and perhaps scheduling of per flow scheduling. There were a number of, well, because the L4S drafts are all transport area working group adopted drafts, the chairs created a set of issues tracker in order to help us manage the discussion. And there are a number of open issues that were created there. All of those have been addressed. I think there may be some that they're still listed as open, but there's a fair amount of discussion on all of them. Many of them are not closed. Key ones here, there were some concerns early on about IP4S and the dual Q coupled AQM draft. Those have all been resolved. That issue is closed. Safe coexistence and RFC 3168 ECN bottleneck. So this has been a fair amount of the discussion on the mailings has been around the potential presence of these classic ECN bottlenecks on the network, and what happens when L4S traffic transits through one of those bottlenecks if they exist. There's been a fair amount of work on coming up with ways to mitigate that, and there's more discussion on that. RTT dependence was another issue that's been addressed recently. And CE ambiguity and reordering, another issue that I think is closed. Looks like I'm running short on time for the 5 minutes here, but there's been a tremendous amount of demonstration of the L4S mechanism, both in simulation and in testbed implementations. Bob and Assad posted thousands of testbed results just in the past few days, and there had been thousands done prior to that. Final statements here. So if L4S is standardized, consistent ultra-low latency for all applications, including web, game streaming, cloud VR, AR, and high-fidelity interactive media, can be rapidly supported. This is easily deployed on a lot of bottleneck links via this dual queue scheme. And so it can be adopted very quickly. The goals and the benefits of the approach lend themselves to incentivizing applications to make the switch to using an L4S compatible congestion controller. It's not seen as a special class of traffic or a type of traffic for certain use cases and not for others. It's intended for all traffic to allow all applications to get significantly lower latency, low loss, and scalable throughput. And for all those factors, we've seen a large support across the industry. A lot of operators, as well as network equipment manufacturers and end system developers are supporting it.
Okay, thank you, Greg. I timed at about 8 minutes. Let's go to the next slide. And whoever's speaking for SE, is that Rod, Jonathan, Pete?
I think that would be me, that's Jonathan. Okay, so first briefly addressing one or two things from the previous slide. I don't think that there is consensus that some of these open issues have been closed.
Jonathan, I can say I would agree with you on the fallback one. I wouldn't say that's closed yet.
I'd also caution on the use of the word consensus, please. Let's stick with agreement for the time being.
Okay, so moving on. So SE signaling method and control loop are very simple and they're designed to be robust. The implementations can be done quite quickly, and we specifically designed them to ensure RFC 3168 compatibility in all circumstances. So whenever we see a CE mark, we respond in the same way as a conventional TCP transport. So the on-wire protocol is also minimal. We use one ECN code point, one TCP header flag. These are statically interpretable, and everything else is left alone. We think hardware implementation of the AQMs is feasible, even though they implement fair queuing or approximate fairness as part of the argument. And the big thing that we offer here is unambiguous signaling on the output, because we have separate code points for a big reduction with CE and a small reduction with SCE, where we're using ECT1 to signal SCE, some congestion experienced. Now in that scheme, the congestion experience code point acts as a safety valve in case the SCE signal is not present or has been erased by something, and also for large capacity reductions in which a series of small reductions might take too long. Now, because we have a safe decoupled system design, which doesn't mandate any particular algorithm to be implemented either at the AQM or at endpoints, we permit we can permit future innovation in the algorithm space, both for the AQM and the congestion control, and indeed in the transport space. We have working examples, running code, public reference implementation, and this includes a simple 1/P congestion control scheme, which is broadly derived from DC-TCP, but using the SCE signaling scheme. So, there are some open challenges with respect to tunnels and fragment reassembly, and a few minutes ago, I posted to the list with a summary of that position as well, and we can discuss that later. I think that's all I need to say here.
I have more time if there's anything else you can think of. Otherwise, the chairs greatly appreciate you yielding back the balance of your time. I will We'll take silence as gold and let's move on.
Okay. So we have a chart to drill a little bit further into the ECT one as an input versus as an output usage. L4S is using it as an input in order to isolate the traffic that only creates low latency from the classic traffic that will fill up the queue. And so it differs from SCE, where ECT1 is now a output from the network to indicate a different level of congestion. And I think for our quick overview of this slide deck, there's not much else to say on this one.
Can I just
Yeah.
I just noticed that the last bullet I had pointed out to Gary that it's being broken. There's not all the text is there.
Yeah,
See
we
if I
have
can
a subject but no predicate.
on the blue side. I'll see if I can
Yeah.
dig out what the slide was meant to say.
Actually, it's some kind of PDF conversion thing, because I think on the prior copy I also have, what that bullet is saying is that IPsec encapsulations strip off the ECT1 markings.
Okay, with that clarification, let's move on.
So whatever we do, it has to exist in a friendly way with competing traffic, and specifically congestion controls that are in use on the internet today. That includes Reno and Cubic, and it also includes classic ECN. So we have discussed a lot on the mailing list, and I think there's no longer really concerns about FQ being a significant cause of some kind of coexistence problems in the network. But we do still have work ongoing for L4S classic bottleneck detection in order to figure out if there's a traditional use of CE marks in the network, and make sure that an L4S using flow backs off appropriately so that it's friendly to other competing traffic. We haven't tried to mathematically define what starvation means, but we think it's one of those we know it when we see it kinds of things. And the most I think we were comfortable saying was that starvation of any class of traffic is not an acceptable outcome. Drilling into that a little bit more, both the L4S and the SCE proponents have prepared the material on this chart and the tables that show their behavior when there are different types of bottlenecks in the network. And at high level, I think it's interesting that both tables are very, very similar. There's only a one cell difference. So I think we can maybe just move on in this fast run and then come back to the second pass.
Almost. Let me come back in the second pass. Those tables are expected to be controversial. Please, everybody, keep in mind you're looking at tables that were prepared from one viewpoint. So it's not that either of these is intended to be a dispassionate representation of facts. This is what each of the proposals does as expressed by the proponents of the proposal. Okay, moving on.
Thank you. Okay, so these things are targeted to be experimentally deployed across the internet, and because of that, there are a bunch of questions about how well they will work. how will an operator know if their network is being crossed by this traffic, and if they should be concerned with that? There has been a lot of good discussion on the mailing list about how these things work with tunnels or with various lower layers. And we also need to figure out how to reclassify in a domain that's not part of the experiment. So if traffic leaks. So here are the summaries from each team on how ECT1 propagates through the internet in the way that they each respectively use it. So I'm not sure anything here needs to be highlighted in our quick overview. Oh, someone, Bob, is on the queue. Okay.
Yeah, I just again, I wanted to say that there used to be a question at the top there, which said something about ECN tunnels and fragmentation. I think it's just a blank space now. We're at the top above the two. Just for people who haven't seen these slides before, they won't know the context.
Yeah. And at some point, if successful or not, these experiments come to an end. And so this is some advanced thinking about what an end state looks like, either success or failure for each one. So as Greg explained already, in the L4S success scenario, ECT0 could actually be reclaimed. In the case where L4S was not successful, then the ECT1 could be blocked by the network and in the long term reclaimed. SE likewise has some thoughts on success. So in the success scenario, both the ECT0 and 1 code points will be used. They're both valid outputs that mean different things. In terms of undeployment, since SCE queues are only changing a ECT0 to a ECT1 or a CE, they're easy to detect when they're doing this ECT1 transition. And so the idea is that people can find them and eliminate them. And then eventually ECT1 can be reclaimed when those SCE are out of the network. And then we asked each of the groups to put together a quick summary of who plans to deploy and use their technologies. So Greg or Bob, do you want to speak to the L4S deployment plans here?
This is Greg. I can comment on this. So this list, and I would invite any of these participants who represent these companies to make a statement if they choose to. But the list on the left-hand side are companies that indicated that they do have plans to deploy L4S. The top part of the list includes end system companies as well as network equipment manufacturers, and lower half or lower part of the list includes network operators, many of whom are cable network operators. I think, as most folks are aware, the DOCSIS protocol has been amended in the DOCSIS 3.1 version to include support for L4S, and that's a mandatory feature for DOCSIS 3.1 equipment. It's a software upgrade on existing equipment that is in the field, providing broadband service to millions of customers worldwide, millions of users. So there are a large number of network operators that will be able to deploy L4S very rapidly, this is a short list of the ones that have explicitly asked to be listed as planning to deploy. But as the technology gets rolled out in equipment, there will be presumably far more. On the right-hand side, there's some additional statements of support from a number of companies who are following this space and evaluating how they would support it in their equipment. And then finally, there's a proposal within 3GPP to adopt support for L4S. And there were a number of companies who signed on to that proposal, either directly to the contribution in 3GPP or at the meetings where it was discussed.
Okay, I timed it up as about 2.5 minutes. Let's go to the next slide, then pick up Jake out of the queue. So 2.5 minutes, Jonathan?
Okay, so we've had specific interest in SCE from 2 major companies who have actually contributed to our research in some way. And this includes HP Enterprise, who helped us with some experiments in the data center space last year. And we've had some, I think Stuart Cheshire won't mind me mentioning him here at this, but the main deployment scenario is in customer premises equipment initially, particularly in the open source variants that are based on OpenRoute and so on. So I happen to be the author of a QDISC that's already widely deployed there, and it would be relatively straightforward to add support to SCE to existing deployments of that, as well as to the Wi-Fi stack in Linux, which now supports a version of FQCODL. So we have a good working relationship with the relevant parties here. So we also believe that high fidelity congestion control is just as attractive if it's implemented using SCE as if it was implemented using L4S. So we think that a good deal of the support expressed by L4S in their previous slide would come along if the decision goes our way. Since the L4S implementation can, for the most part, be converted to use SCE signaling.
Okay, finished.
This is Stuart. Since my name was mentioned, let me just add a couple of words of clarification. Jonathan and I have talked at some length at previous IETF meetings. I have reviewed the drafts and given Jonathan feedback on that. I'm very appreciative that Jonathan has brought these drafts forward to discuss these ideas, because whatever decision TSVWG makes in the end, we will make that decision having considered all the possibilities, and that makes the final outcome stronger. I want to clarify what's on this slide. What I expressed as an Apple representative is kind of what's captured here. We have interest in higher fidelity congestion control. Being technology neutral is also motherhood and apple pie when it comes to networking, and anything that can lower end-to-end delay and jitter is really important for better user experience on the internet. So 100% support for that. However, the heading of this slide is who plans to deploy SCE? And that is an enormous leap from Apple would like low latency on the internet, check, to Apple plans to deploy SCE. And sorry to be harsh, but I need to correct the record here. Apple has no plan to deploy SCE, and I'm sorry, Jonathan, if anything I said gave you that impression.
Thank you for the clarification, Stuart.
Okay, next slide.
David, I was in the queue. You said you wanted to come to me.
Okay, Rod, let's take that pretty quickly though, because we're gonna go through a second time with massive discussion. My bad. Go ahead.
Great. Yeah, I likewise wanted to say something similar to Stuart. I would refer to both slides. Akamai has appeared on both of these, and I mean, plan to deploy is a little bit strong for what we have. I would characterize our position as we are interested in a solution to latency on the internet. We think that this is good and interesting work. Whatever everybody else does, we almost certainly will participate and try to solve the latency problem on the internet by deploying the appropriate technology on our side. You know, we encourage the working group to carefully consider and come to the right conclusion. We are likewise approximately technology neutral outside of the specific technical considerations that we have. We endorse a particular side of this debate exactly. Thank you.
Rod, and brief clarification only, please. Rod, can't hear you. Now you are on mute.
Maybe we can come back to Rod's comment when we do the second pass through here. Okay. So this is the last and final slide that I'll stumble through before we go back to the beginning and do the slow roll through for discussion. But we want to talk about what happens if no decision can be made by the working group. In that case, we would not be able to progress the L4S identifier draft without making some changes to it. And SCE would also not really be able to work by itself without, scoping it to a DSCP or that. So RFC 4774, which talks about that DSCP scoping, would become the relevant thing to go to in this scenario where we can't make a decision about working group consensus on how to use ECT1. So is that clarified? Oh, I see Dave Tott is in the queue. Okay. Go ahead, Dave.
Hey, everyone.
I like your screen name.
Well, it's not unintentional. I put that in years ago. I don't know how to change it. So, if no decision, I would like to stress that the character of the testing to date is focused on 1 and 2 flow tests only, mostly running on stuff that is in congestion avoidance mode rather than in, which I believe the majority of internet traffic is in, slow start. It also has not tested asymmetric networks, very common in CPE. For one example, gigabit, Comcast current gigabit service is 1 gigabit down, 35 megabits up. And its components of the L4S architecture, which include ECN, I would really like comprehensive tests of asymmetric networks overall to be performed for both stuff before we even get RFC test. Favorite test.
I think this is headed into discussion as opposed to a clarification question, so we probably need to come back to it.
My overall point being more testing is needed before any decision making can be made. Thank you.
Jonna, clarification for now, please. We're about to open up for discussion and go back to the top of the deck.
Well, I'll take myself out of the queue. I thought you were opening it up for discussion. If not, I can just hang around and be in the queue.
Okay, hang around. Spencer, this slide or top of the deck?
Actually, the previous slide, I was trying to decide whether to say anything on it. The who plans to deploy, and actually the one before that. I'm sorry. The support in 3GPP is something that I had been talking with 3GPP people about several years ago. Do you all have a sense of how firm that is on current plans for them? Because one of the things with 3GPP is that things that aren't ready get dropped out of releases. And this was a conversation that I was having with the 3GPP liaison to the IETF in a TSV working group meeting probably 3 years ago. I don't think it was 4, but it was more than 2. So I just wondered if anybody had a liveness check on that idea of support.
Do we have anyone on the call with 3GPP affiliation who is brave enough to try to speak for 3GPP?
This is Kevin Smith of Vodafone. I maybe can't speak for 3GPP, but I can speak for Vodafone, that along with Ericsson, we've put through a proposal to enable support of L4S via the RAN group, and it's gone into the SA group, the architecture group accordingly. So it's a live change request from our perspective and something we strongly support.
So I guess the other thing to mention is there's a 3GPP IETF coordination call tomorrow. That this might be a good topic for somebody to bring up, probably from the IETF side, because I know that liaison discussions are on the agenda for that. Thank you.
TSVWG
Yes,
chairs
it's Gary here. Yeah, we noted that, and we've tried to make contact with Lionel just to say we should add that to the agenda.
Excellent.
and
Thank you.
we will bring that up. Response to Dave's comment: would love to join the call. So would a cast of thousands. It's more of a process leadership coordination call. We're not. It's not a smoke-filled room or star chamber.
Okay, Per Villars here from Ericsson. May I make a comment?
Go ahead.
Yeah,
We're
so
still trying to do clarification, but yes, go ahead, and then we'll go back to the top of the full discussion.
It was a clarification about this 3GPP. Since I'm working with 5G RAN architecture, yeah, I just want to clarify that this L4S is working as is with the model 3GPP has for the different bearers, and this ECT marking taking as an input can map to the bearers. And what has been discussed is in particular in this 5G RAN where you have made a split of the base station. So that is an option in the 5G deployment to split the base station. And for that internal interface, there has been a discussion how do we in an optimal way convey L4S, and that discussion has been postponed for future release. It does not mean that you cannot deploy L4S on the 3GPP network. That can be done today, assuming we implement the support, of course.
Okay, thank you. Wes, I think we need to go back to the top of the deck and throw the floor open for discussion.
Can I just make a procedural thing here? Can we try and make sure that we're using the WebEx chat to talk about facts and not to try and distract people from the main conversation.
The WebEx chat is not going to wind up in meeting minutes, among other things.
Okay, back to the top of the slide deck, please.
Yeah. I think we're there, and I think we have Gina and Stuart in the queue.
Hi, Jana Iyengar. I'm surprised there's only two of us in the queue.
Just wait.
Oh, it's too early. So thank you for laying out all the premise and sort of the things. It's really helpful. The chairs did the summary, and I think it's very well done. So thank you for doing that. There's one point that didn't come through, and I want to emphasize on that. And that is perhaps the most important thing for me when I'm looking at these proposals. If we want to have low latency traffic, a solution for low latency networking here at all, we need to have multiple queues in the network. This is not in question in my mind. You cannot get away from this. And you have to have a queue for legacy, and you have to have a queue for low latency. If you don't have that and they mix, you lose the fundamental proposition of having low latency. And this is basically, as I read it, this is a key difference in the classification of traffic between these two schemes. Stuart mentioned this, that ECD1 is an input in L4S, and it's not in SE, and that's actually precisely it. L4S uses ECD1 as an explicit classifier where the endpoint says this traffic is latency sensitive and this one is legacy. So, and in SE, this is implicit. This relies on the network to do this classification. There's the SE proposal has I think the cheap network queuing or cheap and nasty queuing, which is an FQ-like thing that tries to detect sparse flows from non-sparse flows and so on. And I've always cringed at any network trying to figure out from my traffic signature whether my flow should be low latency or not. I don't think that's a good idea going forward. So I would prefer an explicit classification from the endpoints saying this traffic is low latency. And I think this is a significant and fundamental distinction. I just have two more points. The second point is about AQM and congestion control both having innovations. Personally, I don't want any innovation in AQM anymore. We've done this for, I don't know, 25 years. And our experience is basically to me shown very clearly that this may be one degree of freedom too many. Having a very simple AQM in the network allows for work to happen where it really matters and that can be reasonably deployed in reasonable timescales. That is congestion control at the endpoints. And we have experience with DC-TCP style marking. We have experience, when I say we have experience, I'm talking about the 10 plus years of experience that we've had in the industry, in data center networks at Google, at Microsoft with DC-TCP. And that's super, super helpful and useful for low latency traffic. And that's, if we were to ever deploy something like this, I think that's the way that we would do it. The third and final point is that of maturity. We know the amount of work that's gone into L4S. We've seen this work happen over the past 3-4 years, and it's been going through a lot of engagement and conversation with the IETF in and outside of the IETF. And as much as I would like to consider SCE on equal footing, it just isn't on equal footing. I want to be very clear about this. The L4S is far more mature than SCE is. It is obviously seen a lot more thought, has had a lot more discussion, and it shows in the work. So between these 3 points, it is very, very clear to me that L4S is what we should do. I would be very mindful about the fact that if we go with SCE, there are a lot of folks who may not be able to deploy it because the in-network mechanism becomes more complicated. That's it. I'm done.
Off mute. Stuart is next, I believe.
I was going to say several things that repeat what Jana says, so I'll try to make it shorter. High-level goal, from my personal opinion, and to the extent I speak for Apple's opinion, moving forwards, ultra-low latency communication is critical. And that means getting down as close as possible to the speed of light delay. We can't beat that, but we should get as close as we can. I'll give one little personal anecdote with this whole work from home that's been going on for the last couple of months. In Los Gatos, I have Comcast gigabit service. When I'm downloading a multi-gigabyte iOS internal build to install on my phone, gigabit service is fantastic, really, really good. Right now, I'm on this call from Santa Cruz by the beach because we have to shelter at home. So why not shelter at home where I can hear the waves? And here I'm at the end of a little peninsula, far as you can get from the phone office, and I have 300 kilobit per second DSL. Is everybody hearing me okay? Yeah. So interesting thing is that since I moved to Santa Cruz, people have told me that my video calls are much better than they used to be. So my 300 kilobit DSL is performing better than my gigabit cable. And I always knew in theory that latency and jitter were just as important as throughput, but it really drove it home to me. My video frame rate here is not great, but the consistency and the quality of the voice communication is much better than gigabit cable. So that's just one little example of why this industry pursuit of ever more and more throughput with no concern about latency and jitter, we've known about this for 20 years. It just continues to get worse. So for future use cases that aren't just downloading big files, we need to be focusing on low latency. And to get really ultra low latency, we need ultra short queues in the network. And that means an ultra aggressive queue management algorithm to keep those queues ridiculously short. And if you do that to conventional traffic, you really hurt its throughput, because conventional traffic does need some buffering in the network. Not excessive buffering, not buffer bloat, but it needs some buffering. To break through that threshold and get even lower latency requires the end systems to understand this new ultra-short queuing regime and to have a congestion control algorithm that's compatible with that. And following that line of thinking, if we want to break through what we know how to do now to even lower latency for future applications, the input traffic needs to signal its capability. Is it conventional traffic, or is it this new traffic that can really cope with even shorter queues? So that's why, after much time reading these documents and pondering it and trying to work out what I thought, because both sets of documents in isolation look like good suggestions. And if I'd read SCE before L4S, if SCE had come up 10, 12, 15 years ago, I think we'd all be using that now. But what we have now is L4S, which is better because it can push that latency even lower. And given how much I care about future things we're going to be doing on the internet that depend on that, the latency can't be low enough. If we could make the speed of light faster, we could, but we don't know how to do that yet. So in pursuit of that ultra low latency goal, we need to use ECT1 as an input signal. And I'll finish by saying time is of the essence. We've had ECN around for 20 years, and deployment in the practical internet is still close to zero. Meanwhile, modems have gone from 1200 baud to gigabit networking, and yet the gigabit networking to my house doesn't perform as well as this 300 kilobit DSL. So this enormous void has opened up where throughput has charged ahead of latency and jitter, and we're about a decade too late redressing that balance. So I do not want us to be going around in circles on this anymore. I want us to make a decision, make a clear decision, telegraph to the whole industry that this is the IETF consensus and it's time to get on with it. And with respect and appreciation to Jonathan and all the work that he's done, I'm afraid I'm fully behind L4S.
Andrew.
Hi, Andrew McGregor. To avoid repetition, I'm plus one in both Jana and Stuart's comments. I'd just like to say L4S very clearly wins us more, and we learn more by attempting it. So in terms of what should we do, that seems like the bold thing to do. I mean, every musician who has been stuck at home over the last few months would love to be able to rehearse online. That's currently impossible. It shouldn't be, but it is. There's another little detail that I noticed that hasn't been mentioned in between the two. SCE is clearly feasible to implement in hardware. That's a somewhat different thing from L4S, which is feasible on deployed hardware with software-only changes. I can see how to get an L4S implementation working on several species of commodity switch chips, some of which are at this point 5 years old. Whereas SCE would require hardware changes. I'm not sure that it can be done even on the current generations purely with software changes. So it's significantly less deployable in the fast parts of the network, some of which are indeed overbuffered. And with that, I'm done. Thank you.
I just violated my own rules, so I will quickly explain. The goal here now is discussion. We'll advance slides when it makes sense. And we're going to try to make a decision towards the end of the meeting, about an hour or so from now. Okay, next in the queue, looks like Uma.
Yeah, this is Uma. Hi. I have a clarification question. So we have, is there any thought that happened to make this work, that's input signaling, work in MPLS networks? Because there's always this issue with MPLS, how this can be deployed ECN network, right? ECN, even you start with ECN, right? RFC 562 has laid out some stuff, how to do this, even 5129. So, but it's never been effectively worked in MPLS network. So is there any work went on? Because it's so critical here, because input signaling has to be done. So all the MPLS nodes need to know and segregate this traffic in separate queue. So this is much more important than earlier, whatever the work, or whether it's working or not. ECN stuff.
Could I get your name again, please, for the notes?
Sorry?
Could I get your name again, please, for the notes?
My name is Uma, U-M-A.
Thank you.
No, I could speculate, but it's probably not productive is the short answer to work on applying this to MPLS. Bob?
Yeah, I just thought I'd jump in as one of the original authors of the ECN and MPLS draft, which, well, not draft, RFC 5129 you mentioned. Although there's nothing at all to stop any of this working on MPLS, I'm just interested to know what particular environment you're thinking of so that we can think about the problem you've got, because I wouldn't expect many nodes in an MPLS network to be a bottleneck. And so just tell me what you're thinking briefly.
So because this work is so important for 3GPP, for example, So 3GPP and transport network MPLS is heavily used once you cross the base station E node B. So it is important, let's say if a service is terminated in the, let's say, in the core network, I'm not talking about the edge computing stuff. So if its service is terminated, so it has to cross the backbone backhaul network. So that is mostly MPLS. Most of the deployments are MPLS. So how the L4 signaling will be accounted for and put into the separate queue in this MPLS networks if there is no mechanism defined yet.
Did you say L4 signaling?
Yeah.
L4S.
Yeah. Oh, L4S or layer 4?
L4S
Okay.
signal.
Yeah. No, I mean ECN is in MPLS is designed to propagate up to the end systems, and L4S uses ECN signals and encapsulations just as it is, as been pointed out on other slides. So it should just work, but there'll be work to do, I'm sure, because I doubt many implementations have actually tried to do ECN over MPLS, but there are specs for it, but it will need to be implemented. Yeah.
There, let's say, for example, in the ECN case, if some of the MPLS nodes not implemented, the suggestions made in 5129, for example.
Let me try and call time on this topic. Questions being asked. I believe the answer is not yet
Correct.
designed. Interesting area to dig.
And Gori here, this is a topic we can easily pick up in a presentation in TSVWG where we're interested in this in the future. So don't be discouraged, but let's carry on with the agenda at the moment.
Or in the famous words of a past AD, send draft. Bob, I think you're rigor spot in the queue. Appreciate the help in MPLS.
Okay, I just wanted to pick up a few previous questions that I noted needed answers. Firstly, on Jana's point about needing multiple queues, I just wanted to make it clear that we've actually found that having 2 queues is better than having more than 2 queues. Only slightly, but for instance, at the, I think, 5/9 percentile, having an FQ system, we could get 8 milliseconds at the 5/9 percentile, 8 milliseconds. In other words, some packets had 8 milliseconds of delay. Without the 2 queues, without multiple queues, with just 2 queues, we could actually get much less than that. No, I think I've got these numbers right. It was about an order of magnitude less. Actually, I think the 8 milliseconds must be wrong, because I think maybe the 8 milliseconds was what we could get, and the FQ system was an order of magnitude more than that. And that's because when you've got an FQ system, the network scheduler is trying to guess which packets to put out next. Whereas if you've got a first in, first out system, by definition, the first packet in is the first packet out. And so it's always going to be faster if you're trying to keep the queue short. It's an odd result, but anyway, that was that point. Next point on Dave Tart's question about testing, particularly on short flows and asymmetric. All the tests that L4S has ever published have had short flows involved. The thousands and thousands and thousands and tens of thousands of tests we've done have involved mixes of traffic. I mean, we have done single flow tests, obviously, and particularly to understand what single flows look like. But and if you look at the link I put on the Jabber in response to Dave's question, although I couldn't see Dave there, either as Rube or Dave, the tests we've been doing recently, there's all manner of different numbers of short flows as well as long flows. So that should not be a criticism. The second point about asymmetric, that is a good point, and we have tested accurate ECN in that environment, but not the whole system. So that's certainly something I'd add to our testing queue. And one of the points we made in our slides was that we've designed Accurate ECN to deal with ACK thinning, and we've been involved in trying to ensure that Quick does ACK thinning correctly itself, so that the network isn't incentivized to start trying to work out which Quick packets to thin, because thin asymmetric links are a big problem, and they're only not a problem at the moment on the internet because like the technologies like satellite and DOCSIS and LTE actually do the ACK thinning for the end systems. So that's a very important area that needs to be sorted out. Next question, I'll try and answer. There was a point about, I think it was Andrew McGregor, about implementation in hardware, and just to point out that the DOCSIS implementation in hardware, in cable modem hardware by two vendors, has two chipsets, has all been done in software on top of the hardware. There was no, it's a software upgrade, field upgrade. There's no need for any new hardware, and that sort of supports the point that Andrew made, and that's it. That's all the points I wanted to answer.
Miria?
Here. I entered the queue because I really wanted to underline this point about strong incentives for deployment that other people made. For me, the goal really here is to provide a new traffic handling, a new kind of service that enables new congestion control and is based on what we know about what the network needs now. And the whole point about this is, in fact, not being compatible with the old handling of TCP and not being, like, in a sense, like completely fair to this traffic. The whole point is to, like, where possible, have a separation. And of course, like, if this is not possible, there should not be like completely starving the kind of old-fashioned traffic. But I think it's also important to have an incentive to move to this new traffic handling, and to make sure that this provides enough benefit that people actually want to use it. And that's like my worry about if we just pick something up which seems to be much easier to deploy, but only provides a minor benefit, then we end up in the same situation we have been before, where like ECN is not adopted because it's not seen to provide a big benefit. While if we have a chance to change the whole system where we can actually do much more modern things in congestion control at the endpoints, in a kind of separated traffic handling and network, that's a real chance, and we shouldn't game it.
Okay, Dave Todd.
All right, it is the queue of responses to responses is getting overly long, and I have a set of notes. One of the L4S prerequisites, one of the L4S thinkings, is that all traffic is greedy. And that really is not the case in the case of video conferencing, or in the example that Andrew used, it a bunch of musicians, which includes myself, that would actually like to collaborate over the internet. Audio data is incredibly low bit rate. It is the conflict with greedy traffic that makes it very difficult to actually express real-time audio data over the internet. Now, I know that fair queuing really isn't a part of this conversation, but that solves that problem beautifully. Non-greedy traffic never experiences any latency relative to the greedy traffic on the link. 4 years ago, using Cake, over the Sonic ISP and DiffServ, end-to-end, observed there, I actually did manage to achieve a collaborative audio experience. And when we talk about an end-to-end identifier, DiffServ has always been the preferred IETF solution to specifying some network behaviors or a class of traffic on the internet. So I would like to see DiffServ not get scribbled on as much as it does today. And I've really kind of lost track of all the other comments done so far. So that's all I'm going to say so far. Thank you very much.
Okay, Martin, please tell us whether you're wearing your AD hat or not before speaking.
Most emphatically, with no hats on at all. This is Martin Duke. So SCE is good work, and I think if SCE were adopted widely in the internet, it would be a significant improvement in its overall behavior as traffic behavior. I share Mira's concerns about the deployment incentives for SCE. On the other hand, L4S, if we can get it to work right, really is a potentially transformative new kind of service in the internet that is broadly applicable and that enables all sorts of new applications. And I think we should really kind of go big if we possibly can. And really, the only concern for me is this safe or not? And unfortunately, I really ask the working group, when I hear the working group to try to think about that. And it's a daunting thing to try to assess, as Bob and his team have done just an enormous number of tests on a fairly wide range of scenarios. I think there's always room for doubt. The nature of traffic in the internet could always change, and that's a risk that we have to assess. What was this other? So anyway, and of course, there's always there are some sort of unfairness issues in 3168 queues that they've been working to address in TCP Prague that have that are sort of complicated. So there's sort of an argument from humility that just the limits of scoping testing and the sort of the human limits of designing these algorithms may introduce some risk. Because I covered a ton of scenarios, certainly what we were able to conceive of for the most part. So I mean, personally, I'm comfortable with that trade-off, given the payoff to this. But I think that's probably the question for a lot of maybe the undecided people out there is, if you look at this research and the testing that's been done, where do you think we are?
Okay, Jonathan.
I think Martin just brought up the key point, if we can make it work right. And to that, I think I have to point to the tests that the SE team posted a few days ago, which are perhaps less voluminous than the L4S test suite, but they do raise some concerns. They highlight some scenarios in which the L4S heuristic to enable friendly cooperation with existing traffic appears to fail. Now, I will acknowledge that one of the major problems that our tests uncovered has since been fixed. That was due to a bug with handling packet loss. But the detection of ECN AQMs that do not implement the L4S semantics is, I think, not reliable enough yet. And we have doubts about whether it can be made reliable. So I think that is the major question for the working group to consider. Is there enough evidence that L4S is safe to deploy? And if not, SCE offers a solution that should be safe to deploy. And SCE offers two levels of service. The basic service is designed to operate over the general internet with relatively long paths and offer queuing delays targeting about 2.5 milliseconds, which over your 80 millisecond median internet path is pretty much nothing. Now, I remember Stuart talking about his lower latency on ADSL than on cable. I feel his pain because I live in rural Finland. The cell tower is at least a mile away. Right now, I've shaped everything down to 1 megabit a second in order to make this call. And it works perfectly well because I have normal AQM. And I think the problem is that the cable network that Stuart has does not implement AQM at all. So implementing AQM at all is a big latency win. Implementing SCE doubles that improvement. And SCE also has a solution for implementing a low latency service using a separate input classifier in the diffserv field. So please consider that solution as well.
Okay. Before I go on to Roland, Jonna, can I push you down the queue a little bit to let others who haven't had a first chance to speak say something before calling on you?
Please go ahead.
Or rather, Jen, I'm going to do that. Roland.
Yeah, I just want to express that I don't like to see this discussion so much as SCE versus L4S. I think the decision is about the ECT1 semantics. I think that having a different output for signaling the congestion level is more useful for other future approaches too. And so using a DSCP classifier for FRS and using ECT1 as signal is another possibility I'd like to see. And I find it architecturally a bit cleaner.
Okay. Pete?
Thank you. Yes, I just wanted to add a little bit to what Jonathan said about our testing, and that was in regards to the L4S findings. We did find false negatives, as he mentioned. It's generally in the case where you configure the AQM with non-default settings, say lower target or interval, and you can cause it to believe that it's an L4S queue, and you will starve non-L4S traffic in that case. So we need to be aware of that. But also there are false positives, which in that case, if you have, it's only 2 milliseconds more of jitter, that can result in underutilization because the link hasn't been identified as, or has rather been identified as RFC 3168 when it isn't. So there is more work to do on that. They may be aware of this, but I think this needs to be made to work before deployment. And finally, I would question whether ultra low delay, as we're thinking about it, as less than 1 millisecond, let's say, is actually achievable for internet traffic, which is very bursty. There are significant reduces in utilization that you can see in some of the tests that the burstiness tests that we did. I would only like to raise the question that let's make sure that this goal of achieving 1 millisecond delay or less is actually achievable when we can show that we can get 2.5 milliseconds of delay and still get much better utilization in the face of bursty traffic. So I guess that's all. And lastly, I would just comment that I agree with Roland's statement that this is a decision about the code point. This is not a decision between ECT L4S or ECT SCE.
I just want to clarify what you're saying there. Are you saying that it's not possible to get millisecond latency, or are you saying that even if it was, it wouldn't be useful?
I'm saying I think we could all agree that it would be useful if we could get delay from 2.5 milliseconds down to 1 millisecond. What I'm saying is I'm questioning whether that is really achievable with real internet traffic, because if I take a single L4S flow and I simulate Wi-Fi with NetEM, that takes the throughput from 45 megabits per second to 4.5. We just have to look at that seriously. Now maybe things change when there are a lot of flows through a link and the parameters are different. I'm testing, single flows here. I just think it needs to be thought about seriously that is actually an achievable goal for bursty traffic.
To me, that makes a really good argument for segregating the traffic. That for my downloads, yeah, I'd love my 45 megabits per second. For my video conference calls, 4 megabits of low latency would be about 10 times more than I need.
But I thought that the goal of L4S was to have both low latency and high throughput.
And that's why the traffic is differentiated on input, for the traffic that prefers low latency, for the traffic that can tolerate slightly higher latency to get better throughput.
Okay, I think I think others can contribute further from this, but I think I've raised what I wanted to raise for now.
Thank you. Okay, next three, and in terms of queue management will be, I'm going to do Jake, go back to Jana, and then Bob. So Jake?
Yeah, thanks. Going back to the points that Miria raised, the core issue here is that to me, one of the major core issues, I should say, is that it breaks 3168 queues. So this is also a point Jonathan made. The regular ECN actually does a lot of good here, and we're starting to see rollout. And what I don't want to see happen is, and what L4S with a inadequate detection mechanism, which it's questionable whether it can be made adequate to me. This breaks regular ECN 3168 queues, which are in the process of gaining some level of adoption. And I would urge that we not disrupt that adoption as it's kicking up. Thank you.
Jana Iyengar, just very quickly to Jake's point, I think we waited 25 years for 3168 to get deployed. I'm not holding my breath for seeing it get much more widely deployed than it currently is. So I wanted to quickly respond to a few things. One was that I had mentioned multiple queues, and Bob corrected me. Or not corrected me. Bob said that 2 queues are about 2 queues versus many. My point there was to say that we can't have one queue. We need to have at least 2 queues. And I can believe that 2 queues are adequate. I need to think a little bit more about that. But I think it's clear to me that we need at least 2, and we need to move away from 1 queue. So we need a differentiator. Implicit or explicit is a question. Explicit to me is much more sensible and something that I would want to build. Implicit has a lot of problems. On the traffic mix, I want to correct the record here. In general, people want to be very clear about how it is that traffic is divided in the network. Typically, yes, 80% of connections, or a large number of connections anyways, about 80%, tend to be small connections, but about 80% of the bytes by volume tend to be from really long connections. So whenever anybody is doing any experiment with this traffic mix, please be mindful of this. Not all, in terms of bytes, your traffic is mostly going to be from long flows. One thing that I would like to mention for the folks going forward, and this is speaking to Martin Duke's point about safety. The experiments need to start considering BBR as a real congestion controller, not just the sawtooth. The sawtooth has become, is quickly becoming old news in the sense that there's a lot of deployed traffic now that is BBR or something else. It is very important to consider this going forward if we want to have real deployment in the internet. I basically wanted to also raise the high order point here that yes, safety is important, but we can discuss those things in the working group going forward. This is not about finalizing the details of a particular mechanism, but it's important for us to remember that deployability is absolutely key here. As Stuart pointed out earlier, we waited for long enough. We should have done this. We should be ashamed of ourselves that we haven't done this yet. And we are still trying to figure out precisely if we can get RTT fairness. It seems like a really silly discussion to be having when the high order discussion we should be having is how can we get low latency right now in the network. For that, what I want to see is a proposal that we have been working on for a while that we can move forward on. And we should be all in agreement that we want to move forward and actually get to the point of having low latency networking becoming a possibility really, really soon. So please keep in mind that deployability is absolutely essential here. Safety always takes hits here and there in terms of what happens to legacy traffic. To me, that's we can figure out what the cost there is, but the future, there's a lot more of the future than there is of the past. So let's keep that in mind going ahead.
Bob is next, but the first thing I'm going to do is I'm going to transfer queue management to Wes, since I believe I'm up after Bob in the queue.
Okay, again, I wanted to try and pick up on some points. Very quickly on Dave Tutt's saying that L4S's assumption is that all traffic is greedy. That's a sort of the wrong way around. L4S is aimed at being able to ensure that greedy traffic can also have low latency. It doesn't mean all traffic is greedy. And that's a lot of the traffic that's being tested, and Ingemar's been doing a lot on this, is not greedy. But the point is, when other traffic comes in, or when the capacity reduces on a radio network or whatever, it becomes greedy, and you want to make sure you keep the low latency. It's the consistent low latency, whether it's greedy or not. And it may adapt down, but there's a period when it's it hits the ceiling, if you like. On testing of the fallback, I did jump in earlier to say, I'm not yet happy with it. We haven't completed it yet. It took much longer than I thought to get visualization of the large number of experiments. So because we thought we had it working, and we'd tried a number of cases and all the rest of it, and they all seemed fine. But then it's only when we explored the whole space and managed to visualize it that we saw, okay, there's this pattern here. And so we are at a point now where we can very much more rapidly try out new algorithms and see very quickly whether they work across the whole space. The point that Jonathan made about and Pete about false positives and false negatives, all the false negatives, which were where let me get the false negative thing the right way around. That means where you think it's my brain's gone dead. Right, I'll do the false positives first, because for some reason I can find that easier. False positive means you think it's a classic queue, but it isn't. And so you continue to behave as L4S, or the L4S flow continues to behave aggressively, thinking it's a classic queue, and it isn't. All the cases where that occurred were where there wasn't any classic traffic. Whenever there was classic traffic, we didn't get those false positives, apart from one. There was one case in I think now 4,000 experiments, and you can find that red dot, if you like, in the experiments. But the other way, we have got far too many false negatives at the moment, which is where L4S changes to classic when it doesn't need to. And I don't like that, because obviously that's not going to be good for L4S service. It's generally at the low rates, and that's because we thought that when it's at a low rate, it's not going to matter that much, because we looked at the cases where we didn't run the algorithm, and we found, well, okay, even if it gets it wrong, it's still not particularly unfair, because there isn't that much rate to be unfair in. And when TCP Prague is in a squeezed capacity, it tends to become closer to 50-50 with cubic and other types of flows, and that's actually borne out by all the experiments. If you look where there's false positives, did I say that right? I can't get it right. Anyway, where it's getting the detection wrong, and it's switching to classic when it shouldn't. It's still, in terms of fairness, it's absolutely fine. So, but I do want to get rid of them, because it's underutilizing the link, and I'm sure we can do better now that we can see those points. Then what was the next one? Oh yes, Jonathan mentioned that SCE has focused on being on the safety issue particularly, and it is inherently much safer in that it's not going to have those fairness issues, but that's not the only possible safety issue. You've got a in L4S you've got an ambiguity for the CE code point, but in SCE you've got an ambiguity for the ECT0 code point. And if there are black holes, and Dave Tart discovered what looked like a bit of a black hole this morning, in fact, on his tunnel software. But if you've got a firewall, for instance, that is black holing ECT1 packets, SCE is taking all ECT0 traffic, whether it's part of the experiment, SCE experiment or not, and it's marking it with ECT1. And then if the end system understands that, it will do something about it. But that means that the experiment is being applied to all traffic, not just the experimental traffic. And if there is a problem with ECT1, the network is then switching stuff over to ECT1 and throwing it at that problem, and then that problem kills it. So to say that SCE is inherently safe, it's inherently safe for the problem that Jonathan has thought he needs to worry about safety on, but there are other problems on the internet.
All right, thanks, Bob. I'm going to go to.
Okay, so this is David's speaking without any hat. Observe that discussion so far has focused very much on the edge networks. I've heard cable modem, we've heard DSL, we've heard 3G. Want to inject more of the internet into this. In particular, my background is data centers. Latency is a controllable problem in data centers. It's nowhere near as bad as you can build up in a base station or access point for a wireless link. But there's a bigger problem, which is incast. Everybody tries to send to the same queue all at once. Yeah, stuff gets synchronized. The one over P congestion controls like DC-TCP are a good solution to this because they tend to run the queues empty. DC-TCP has been slow to deploy in data centers due to the risks of getting it into the same queue as conventional TCP traffic, whether it's Reno or Cubic. You're one fat-fingered mistake away from putting those two in the same queue, and then the TCP traffic, whatever's using it, breaks. And to really foul things up, all it takes is a runaway config script. I will say that the use of the two code points to clearly distinguish CE and SCE traffic and swapping over DC-TCP and the like to use SCE is very attractive in making DC-TCP easier to deploy in data data center environments. And the other observation is that to the extent that the trade-offs among these appear to vary by network type, that's heading into the problem area that DSCPs and DiffServ were intended to solve. And that's it for me.
All right, thank you, David. And then next in the queue is Aiden Burstein.
Hi, this is Idan from Mellanox. Mellanox is doing networking for data centers, so I'm going to bring our point of view from the data center world. So when you have a controlled network, a controlled environment, where you know your infrastructure networking hardware, you know how it's configured, you control it, then you typically differentiate your services with the traditional ways of differentiating services. For example, priority or DSCP. Those are valid options that actually exist and people are using them. For example, Mellanox is deploying in data centers today a transport which is hardware assisted. hence it has different characteristics of operation. Like for example, it can push a lot of bandwidth very fast and starve other traffic types. And this is typically and the way it's differentiated from other services, from other transport types or other services in data centers is typically priority or DSCP. I think from my point of view, we have 2 bits in the IP header that are there for enabling congestion control algorithms. And as DCTCP have shown, ECN is significantly important. Even this 1-bit notification is significantly important for enabling low latency communication. Hence, I think that using these the reserved the reserved state in this 2-bit field for.
Can I just clarify what you said? You said different congestion control algorithms. Did you mean that, or did you mean different queuing algorithms? Congestion control is at the endpoints, queuing is in the network.
What I meant what I meant is that for example, when DCTCP was first deployed, the data centers operators typically differentiated 2 services running on 2 different congestion control algorithms according to priority, so they would not interfere with each other. So you would have 2 different congestion control algorithms being mapped into 2 different services in the network, for example, priority or DSCP.
Thanks.
And this is what people are doing today with high-speed transports, like Rocky and IWARP, which are hardware accelerated. So anyway, we have only 2 bits in the ECN field, and
Can you get to the point?
Yeah, and better congestion control. Better congestion control eventually implies better latency, and I think this is not marketed well at SCE today. So I think that if I'm not speaking about the SCE proposal specifically, but I think that if we will use these bits, this reserved state as an output from the network, we will be able to enable low latency traffic in data centers. And the way we would be able to enable this is by enabling congestion control algorithms that would react faster to congestion states. And this, I think, would be significantly important for data centers. From this, from a data center standpoint, I do not understand how L4S enables something further than what is enabled today with DSCP and priority, and that's my point here.
Thank you. And Ingemar is next in the queue.
Okay, do you hear me? Hello?
Go ahead. Yes.
Okay. It was about the discussion on jitter in Wi-Fi, and that makes it more or less meaningless to have low latency service. But I want to point out, as I also explained on the list, that we shouldn't use today's snapshot to sort of determine what just tomorrow's technology can bring. Because if you look in 3GPP access, then we have been with LTE, we have been using 1 millisecond time slots for a long while, and within or we probably will start with the 1 millisecond time slots, but there is option to use the shorter time slot, and with that you will reduce network jitter. And I can imagine that other access technologies and also network transport technologies will also evolve over time. So it will go down in the network, that I'm fully believe strongly. And then also discussing about not greedy traffic, and we are looking at L4S pretty much from a not greedy traffic perspective, and in this case it's about gaming traffic and remote control of vehicles. And then you typically have some upper limit of your bitrate, could be 10 megabit per second or 40 megabits per second or whatever. And also we have a case where you have the sources, which are video decoders that are also that are limited in their bitrate that they produce, so that is more or less not greedy traffic all the time. And that's what I want to say, that it's not about only greedy traffic in this case. But L4S can give a possibility to make not greedy traffic cooperate with greedy traffic, or the same links. That's what I have to say.
Thank you. And next in the queue is Nikki P. Nikki P. Okay.
Hi, sorry, I thought I had unmuted myself, but I guess it didn't take. This is Nikki Pantelius from Broadcom. We are in, among other things, the cable access space, making equipment both for the cable modem and for the head-end equipment that is at the operator premises. I wanted to comment on an item that was on a later slide about SCE having been implemented at the CPE and at the data center. The spot where we sit in the network is actually neither of those. We are usually the bottleneck on the link, and we are not either a Linux stack running in a laptop or kind of big iron switches and networks running in a data center. And so our implementation concerns at this point in the network, I think, are very different. And some of the things that were listed that are important to us are not having to inspect the layer 4 header, being compatible with accenting, and being able to do this with a dual queue implementation. In particular, the implementations in progress that we have that Bob Briscoe mentioned on cable modems using existing hardware, those would definitely not be possible with an approach that requires fair queuing. The per flow queuing and scheduling would be very burdensome, I think, at both ends. Even if we were to create new hardware, these things would be very burdensome. So when we did consider that early on, when we were looking at how to reduce latency in cable networks, we are now pretty far down this path of using ECT1 in the manner that L4S wants to use it. And we are very happy with how that's worked out in terms of the implementation trade-offs. That's all.
Great. Next in the queue is Ram Ranganathan.
Hi, I'm Ram Ranganathan from Comscope. Yeah, I'm also in the same space as Nikki. I'm in so Comscope is in the business of making cable modems and head-end equipment called CPS. And there was discussions related to AQM in cable networks and the use of it. Definitely increasing. Latency is a much more critical issue than what it was 3, 4, 5 years ago. So AQMs are rolling out, and we have actually been working on experiments to look at the behavior with traditional AQM support, as well as now with the newer, dual queue with L4S kind of capabilities and ECN support. And what the difference where we see is AQM is doing its thing. Definitely, it is a very powerful tool. It reduces latency. The challenge it faces in keeping a consistent low latency in some cases is when there is a bigger pipe. You have a lot of bursty traffic from different flows. So the difference, what we have seen with our experiments that takes us with an L4S and an ECN style is a consistent latency under 10 milliseconds, right? So with AQM, typically you get that, but there are bursts where it's unable to handle and maintain it when the burst comes together. But with an L4S and a dual queue separation, we are consistently 5, 6, 7 milliseconds in the window to handle specifically the low latency traffic. And so far, at least, we have not seen a single impact on, at least a significant impact on the classic traffic that's mixed in that window. So if you're wanting to offer a low latency service like a URLLC or something, it's a great way to approach it. And having something elegant like L4S based ECNs is probably the neatest way to do it in our opinion. Thank you.
Thank you. And next in the queue is Greg.
Hi, I just wanted to come back to one other point that I think is important to think about here, and that is the that these bits are fairly precious, right, in the IP header, and with the L4S proposal, the idea of potentially being able to reclaim the ECT0 code point at some point in the future for another purpose is a pretty attractive characteristic, whereas with SCE, all of the code points effectively in the ECN field are used forever. So I think that's something that we should consider, again, for the long term for deployability and use of low latency and ECN across the internet, having the ability to do the next thing at some point in the future. It's a pretty important one.
And then Lars, you're next in the queue.
Can you hear me?
Yes.
Okay, I'll try to be quick. So this is a meta comment, right? No matter what we do, we need to make a decision now. I think Jana has sort of been alluding to that too. Right, we've waited too long already. This is, progressed at the usual speed of the IETF transport area, which is not exactly fast. So the last thing I want to have is more discussion on this. We need to come to a decision based on what we know now, and then we need to live with it. So I don't want us to, the one thing I want to take off the table is to throw more time at it, which is basically not doing anything. I do want to do something. I almost don't care what it is, so I'm not going to state my favorites here, but we need to come to a decision now.
That's good. And then Stuart, you're next in the queue.
Thank you. I have 3 comments to make that are reactions to things I've heard over the last half an hour. One is we've heard more than once that there's no point lowering latency because what about Wi-Fi? And I have to say I find that a very pedestrian and unambitious stance. Some things are connected by Ethernet that has sub-millisecond latency. And we are doing work at Apple on lowering the latency of Wi-Fi. And we're also doing work, including on this call, to lower the latency in the internet. So to point at some other thing and say, well, they suck, so we shouldn't try, I reject that argument. Second point is I've seen some assumptions that video conferencing traffic is inelastic and will just overflow the network because it's not congestion controlled. I think we all know that's not true. Even video conferencing traffic will scale its frame rate and its image quality to fit the available capacity. The only difference is that it wants to do that while keeping low latency. And then the final thing I've heard is some fear that traffic will cheat and set CT1 to get better treatment in the network. And that is not viable because the difference here is in the L4S proposal, ECT0 traffic says, I want the best throughput possible with low latency. And ECT1 traffic says, I want even lower latency. And if that means not being quite so far out on the curve of maximum throughput, I'll trade off a bit lower throughput for low latency. So the only benefit you would get by cheating is lower throughput. So if what you want is ultra low latency and you don't mind the lower throughput, that's not cheating, that's getting what you want. If you wanted the highest throughput, then that cheating just shot yourself in the foot. So the good property of any system like this is that there has to be no incentive to cheat. If cheating actually gives you worse behavior, then there's no incentive to do it. So I'm not concerned about Wi-Fi latency and jitter because work is being done to fix that. I am not concerned that video conferencing traffic is inelastic because it's not. And I'm not concerned about cheating because there's no benefit to cheating.
Thank you. And then next in the queue is someone whose ID is L. Umuskar.
Francisco. I have a few comments, very short. One is about safety in the internet. So all this discussion is mostly indeed for the access network, but we have to consider that there are many examples where you may have bottlenecks going through the network, through the aggregation network, transit networks, etc. So which means that safety is important because in those scenarios, you're going to get all the endpoints need to guess what to do. AQM there won't be able to manage that. This is important to consider. So it's something that, of course, is going to break all the considerations about low latency because it's going to fade away. So this is important. So it's not just a data center use case where you have a single switch and everything is managed locally. So it's not going to be the case. The other point about elasticity for applications like WebEx, the one we're using right now, it's not elastic because all the video streams are sent no matter what if you have enough bandwidth to send them. So if you have a video quality 1 or video quality 2, they will be sent no matter what. And so there's no elasticity. They are sent in any case. So there's no condition control most of the time because you're using FEC.
You're 100% wrong on that. Because when I'm on gigabit, my upload stream is 2 megabits per second. Here I'm on 300 kilobits. There is no way it can send 2 megabits over a 3 kilobit link. It has to adapt to the available rate.
In any case, you're not going to use more than 2 megabits per second. So it's not elastic. I mean, it's of course, if you have a very low uplink, then you may see one of the two video qualities because there's not enough bandwidth to use the two, but that's it. There's no typical elasticity. It's mostly FEC. But anyway, this is just the other thing about wireless. So wireless, and so there's going to be A2 AX coming in. We need to support wireless as well. And we need to consider that it's going to be very heterogeneous, meaning there will be a wireless bottleneck sometimes not. So there will be an uplink bottleneck, sometimes just the uplink and not the downlink. And maybe this is going to change at night, where you're going to see the aggregation network being a bottleneck. And so when we say there's going to be very easy and simple to get dual queue everywhere, well, it's going to be very simple because dual queue will be needed only in the CMTS or in the cable modem. This is false. We will be many bottlenecks will coexist in the future for a very long time. And so safety is going to be an issue as an important feature that I consider very important for all applications, not just for low latency applications. And I'm done.
Thank you. And Jonathan, you're next. I have a couple people further on that haven't spoken yet, so just be short if you can.
Okay, thank you. So I've heard a number of comments that basically boil down to Alpha Vesper's been worked on for a long time and we should just get on with it. And I'd like to remind everyone of the sunk cost fallacy here. So the major point to remember here is that it has not yet been properly demonstrated that the ambiguity of the congestion experienced signal has been resolved. We have counterexamples, and I think Bob admitted that more work was needed. So I think that a decision in favor of using ECT1 as an input to the network would be premature if taken today. And if we want to take any decision today, well, it would be better to decide not to use ECT1 at all and just to use RFC 3168 as it is now. And that would already be an improvement if more widely deployed. You don't need a fair queuing for that. You don't even need approximate fairness. You just need to actually deploy it. And in recent years, we now have AQMs that are much easier to configure and deploy than before. Red was a bit of a disaster. Cordell is much better. Pi is much better. So please deploy ECN in some form.
Okay. And then Sebastian, I think you plus queued and then minus queued. So skipping you.
If I can say a few words towards.
Can I just remind you only have 15 minutes left to get your final questions in. So make sure the answers are short, please.
Thank you.
Questions are short. Go.
Can I?
Go ahead.
Okay. So just as an answer to Stuart, he noticed that cheating his way into the L4S low latency queue is backfire because you're getting less throughput. But the point is, as currently implemented, the L4S low latency queue gives you both higher throughput and lower latency. There is really no incentive not to cheat. That's all I wanted to say.
Thank you. Then Anna, you're next.
Anna, are you there?
Sorry, my mute button didn't work. Yes, I wanted to ask a clarifying question because I was also a little bit confused when Stuart talked about the two queues. My understanding is that the goal here for L4S is that all the traffic should go in the L4S queue eventually, and this is also how you could reclaim the ECT0 mark. So I was a little bit confused about part of this discussion.
Would you like to respond?
Just wanted to clarify that.
I'll respond very briefly because we don't have much time left. My expectation is that we will have legacy greedy traffic on the internet for a long time. So I think at this stage, hope of reclaiming ECT 0 is about as likely as retiring IPv4. So for the foreseeable future, we will have smarter congestion control algorithms that keep queue short, and then we'll have an enormous long tail of old devices using classic Reno that will never be updated, and they will be in the other queue.
Great.
Yes. So just to understand, so that I understand correctly, this is I agree we will have a long tail, but I guess the hope is that for different types of both the high utilization and the low latency traffic should be able to go in the L4S queue. This is how I have
maybe a clarification from me, Koen here. I think we will need at least two queues for a while because there is still the drop-based traffic. I guess not all traffic will use ECN in the future as well. So we still have both options, let's say, but from the other hand, it's possible to use the L4S queue also for high throughput. It depends, of course, how much bursty traffic is mixed in it, because it will then make gaps where the throughput cannot be fully utilized. But if you really want high throughput, you still can use the let's say the classic queue, even without ECT0, because drop-based packets are still there. If you're non-ECT, you will always be there. And I agree also that ECT0 will take a very long time to get rid of that. So it will still be available.
May I just add a data point that the ECN nonce was likely to have been used in possibly one network somewhere in Scandinavia on the internet, and it took 20 years to reclaim that code point.
So I reckon we've got to the point where we can try and figure out what we've learned, apart from the fact that it takes a long time to record points. 2016, we had a pretty strong consensus to start work on L4S. And I think we've heard quite a bit about what people have thought since then, and that's great. Do we have enough information to make the decisions we need to make today? Wes, do you actually have questions you want to ask?
Well, maybe I'll summarize what I've heard. See if that generates some questions that you'd like to follow up with. But there's been a great discussion, and I think there continues to be support for using ECT1 as an input. We heard a range of opinions, though, so this is not unanimous support, but there does seem to be a majority. Not sure that it's a consensus yet, but it's a majority that spoken have expressed support as an input. There are definitely some that would like to use it as an output, and some that would like to use DSCP as well. So I think we heard the whole spectrum of thoughts. If we go forward using ECT1 as an input, there are concerns about the classic bottleneck detection and fallback. So that will remain an important bit of work that we'll be doing. There sounds like there are bits of open work that we will need to continue to discuss related to some data links like Wi-Fi. And also, I think there's still some discussion probably around the cheating scenarios and details to be worked through about what happens with flows that cheat. So those sound like sort of three areas of ongoing work needed if ECT1 as an input is indeed the consensus of the working group. So that's my summary of what I've heard. And maybe Gori, David, if you want to ask some questions to the working group, it's a good time to do so.
From my perspective, when we did the BOF on L4S, people were very unconcerned about the transport reaction and the fallback case. They thought these were things in endpoints that would eventually be fixed as TCP and other transports evolved. And yet we heard quite a lot about that as being the sticking point. So I'd be interested if that really is the thing that should stop us doing any standardization work, or whether it's a thing we think we can just fix in the specs as we move on, because this also seems to be an important part of knowing which way to go ahead. I see Jana in the line. Jana?
Hi, God. We expect to have work to do in the working group after this point, right? So it seems to me that we should be looking to see if we can make the decision on ECT1 so that we can stop running around in circles between these proposals and then figure out what work we actually need to do in the working group. It sounds like the things that you're listing, Wes, and the point you're making, Gori, are basically work that we will want to do and we can do going forward in the working group. These are completely solvable problems. We just have to figure out how to do them. We may not have perfect solutions, but such is life. But yes, let's please make the decision so that we can work on the problems going forward.
Okay, David, you got a comment on that?
Yeah, I think the safety of whatever we roll out is crucial. This is something that influences what we decide to do. We must not break things out there as part of working towards improving them. There's an interesting piece of technology that has been mentioned so far, and I apologize for doing this late in here, which is in a different context, the NQB PHB draft. There is the concept of queue protection or traffic protection that might apply the class disincentive that seems to be envisioning. It might be something that could help down the road, but right now I don't think the safety case is there for L4S as we currently understand it.
This is Stuart. Sorry I just had need to interrupt.
Stuart, go.
Just with a procedural thing. Before these PDFs of the slides, well, they have been posted. If they could be updated, I have a request from Apple management to remove Apple's name from the slide that says who plans to deploy SCE. As you know, Apple PR and marketing manage Apple statements very closely, and they object to Apple's name appearing on this. That was not sanctioned by Apple PR. It is not Apple's marketing or engineering position on this statement. So they feel that slide is misrepresentative. So if we can just update the slides, that will avoid that having to escalate.
Thank you, Stuart. We definitely do that because we had people whose lawyers were unhappy on one or two other names in other places, and we simply removed them. So we will update the slides correctly.
Thank you.
We could talk more, or we could try and vote in some way. Do we have any way we can actually take any hums or counts? Martin, are you helping this? What items do we have to find out the consensus?
There's no, at this time, there's no technical solution for virtual hum. That is something that is in work for 108, possibly.
We all have microphones.
Yes, but so I think there's the list. There's we could use chat. There's not really a great solution there. I would like to say that I think there, in terms of kind of characterizing the positions here, there are probably three things that I've heard. One is there are people who are pretty comfortable with L4S as it is and want to move full speed ahead. There's another group that thinks it's fundamentally broken and either wants to put it as a DSCP, which would certainly solve whatever safety issues there are, or really not pursue it further. And then there's a third group that has specific data they need to see, but wants to continue to work on L4S in that direction.
Yeah,
Martin, I don't mean to, so I do want to note that yes, those positions are there, but I think the key here is the size of the group that has those positions.
Yeah, by no means am I claiming that it's split evenly three ways or anything, but I think if we are discussing this I think we should be aware of those three positions if we're trying to figure out how to structure a vote or consensus call.
Can I offer a suggestion? You have the blue sheet. Why not have an indicator added to your name? It worked pretty well when we tried to enter our names. It's all real time, and we can all just input our own point or a view there.
Yeah, why don't we try it? What is it we're going to ask for? Why don't we try marking the blue sheet with a marker to see whether we crash Etherpad or not? And
Can we have Alyssa comment first? I think she may have some constructive advice here.
Yeah, I was trying to respect the queue logic. This is Alyssa Cooper. Obviously, total outside observer to this, but just want to make a suggestion. Having like 3 minutes left in a working group meeting is not really enough time to formalize a consensus question properly of this nature. Even if you guys were in person, I think it would be hard. So I think it would be good to take a little more time, formulate what the question is. I do think, you know, based on Martin's summary, it's kind of a 3-part question. And one of the options, in addition to, you know, which of these 2 protocols do you think should use the code point, would be you need more information. You want to continue gathering more information. So it's not just a binary. And I think that probably makes the Etherpad voting option off the table, as well as the fact that we're having a little bit of difficulty with Etherpad connectivity right now. I'm back channeling with our IT people, and it's not stable for everyone. So I think good structured, clear set of questions to the list where people can evaluate whether, you know, what that looks like, and also whether any new arguments come up in that context would probably be a little safer from the consensus judging perspective than trying to do a quick Etherpad vote with 2 minutes left.
Yeah, we have 1 minute left, and we will talk with our ADs and other wise people about how to take a real sense of this, because there's, I don't know how many active people, but there's probably 40 or so people regularly commenting on this, which is a reasonably large group, apart from those who have said that they supported one way or the other on the list. So we need to find those questions, and we'll find a way for people to express their thoughts on them, which helps us build the right answers. Anything to finish with?
For what it's worth, people are putting
no,
stuff in on the blue sheet.
There are about 3 or 4 people in the queue.
People. Yeah, we have time for that many people to comment, though. Jana and Bob.
I'm going to say, I think we're just about done, and I think Alyssa's suggestion that we've got to figure out what the possible positions are or questions are to get consensus and try to get somewhere on the list with at least Martin involved, Alyssa if she has the time and interest to help out.
As you asked, so I'll quickly say in 10 seconds. You can figure out the questions, but please don't make further discussion one of them. That's all I've got.
Yeah, and I wanted to say that there is no reason to delay too much. So an interim as quickly as possible, please, because there are other standards bodies watching this and waiting this, and the IETF's starting to look embarrassing.
I agree, time is very important, and we still have an experiment where we can learn a lot of real deployments. So as long as we are doing experiments in lab trials and trying to find situations or assume situations, we should do the real thing. And that's important to as quickly as possible learn from the experiment.
Okay. We are out of time now.
Good job, guys. Thanks for navigating this difficult conversation.
Done yet?
Well, I know I didn't say you were done. I just said you did navigate it.
Yeah. We're not dead yet.
But still, thanks. I think it was a very good conversation.
Thank you, everybody.
Quarter.
Yeah. You can either say bye-bye or make whatever comments they like. Bye-bye, everyone.